trigonometrical equations. Okay, so when you're going to discuss about trigonometrical equations, you must have a brief idea about the standard angles. Okay, let me give you a briefing about the standard angles of trigonometrical ratios. We have 5 angles: 0, 30 degree, 45 degree, 60 degree, then 90 degree. Okay, now how to find the values? These are the T ratios, trigonometrical ratios, whose values you are going to find out. Okay, suppose we are writing for sine. Okay, since the whole numbers start from 0, so keep writing whole numbers 0, 1, 2, 3, 4. I repeat once again. You can see the 0 degree over here. Okay, now since whole numbers start from 0, remember that, so keep writing whole numbers 0, 1, 2, 3, 4. Now divide each of them by 4. Okay, and get the square root. This gives you the values of the first row for all the values of sine: 0, 30, 45, 60, 90. So the value of this comes to 0, the value of this comes to half, then we have 1 by root 2, then we have root 3 by 2. Okay, and for this we have 1. Okay, this is how you have to find for sine. I repeat once again, we kept on writing for whole numbers starting from 0, 1, 2, 3, 4, divided each of this by 4 and then got the square root. That gives the value sine 0, 0, sine 30 degrees half, sine 45 degree 1 by root 2, sine 60 degree root 3 by 2, and sine 91. Now to write the values of cos, okay, write this in decreasing order, because for cos, more is the angle, less is the value. So write in diminishing order. It is 1, then we have root 3 by 2, then 1 by root 2, then half, then 0. That means cos 0 degree is 1, cos 30 is root 3 by 2, in this way. Okay, now to write the value of tan, since you know that tan theta is equals to sin theta by cos theta, so keep dividing this and you get the values of tan. So 0 by 1, that is 0, 1 by 2 divided by this is 1 by root 3, that is the value of tan 30, then dividing this by this we get 1, that is tan 45, then tan 60, this divided by this you get root 3, and for tan 90, 1 divided by 0, since 0 cannot divide any number, so we write infinity for this. Okay, now to write the values of cot. Okay, please remember the sequence: sine, cos, tan, cot, sec, cosec. Okay, now for cot, you know that you can write it in diminishing order, you can get the values, or if not, you know cot is cos by sine. Okay, so that is how you can get. So for tan, you have written 0, 1 by root 3, 1, root 3 and infinity. Keep this in decreasing order: infinity, root 3, 1, 1 by root 3 and then 0. This gives you the values of cot. So it's very easy to remember. If you write sine, keep it in decreasing order, you get cos. Then if you write tan, keep it in decreasing order, you get cot. Now for sec theta, okay, sec of 0 degree, you know sec is reciprocal of cos. So keep reciprocating all these numbers. Reciprocal of 1 is 1. This gives you 2 by root 3. Then we have 1 by root 2. Then we have 2. And 1 by 0 is infinity. Okay. To get the values of cos, okay, sorry, cosec. To get the values of last T ratio, that is cosec. Okay. You can either write this in decreasing order, that is infinity, 2, then we have 1 by root 2, then we have 2 by root 3, and then we have 1. Or you can reciprocate the values of this. So 1 by this is infinity, reciprocal of this, reciprocal of this. So this is the quick recap. You can do it in examination answer sheet also, in the rough column sheet. Okay. Now second thing what we require for trigonometric ratios is complementary pairs. This relation is being derived from the table. and the pairs exist for sine and cos. Okay, sine 90 minus any angle that is complementary will give you cos of that angle. Okay, similarly cos 90 minus theta gives you sine theta. Okay, so this relation stands for sine and cos. You can apply any angle. Suppose we are applying sine 90 minus 30. Let us take this sine 90 minus 30. Okay, this is equal to cos 30. You can prove it. Sine 90 minus 30 is sine 60 and cos 30. Yes, both are equal. Sine 60 is also same as cos 30. So you can see these two values are same. Okay, so this is our first pair. The second pair is for tan and cot. Tan 90 minus theta within bracket equals to cot theta. Similarly cot 90 minus theta, this is tan theta. Then we have the third pair, that is sec and cosec. Sec 90 minus theta is cosec theta and cosec 90 minus theta is sec theta. Okay, so make sure that when you are applying the equations, try to eliminate these. Okay, suppose we have cos 40 degree. Okay, that means for cos theta you can write sine 90 minus theta. So this can be written as sine 90 minus 40. Okay, so suppose if it is sine 30 degree or 35 degree, then for this sin theta equals to cos 90 minus theta. So you can write it as cos 90 minus 35. Okay, so the elimination should be in this way, right? Now let us solve few questions based on trigonometrical equations. So our topic today is how to solve the equations in trigonometrical ratios. Okay, here when you are going to solve the trigonometrical equations, you need the application of simple equation, quadratic equations, simultaneous equations as well. Okay, so let's do one simple question. Now this is type 1 question. Okay, we are taking a simple equation, that is 2 sine A equal to 1. This is the question. Okay, so this can be written as sine A equals to 1 by 2. Okay, make sure when you are solving trigonometrical equations, both the sides, left hand side, right hand side, should have the same trigonometrical ratio, right? If it is sine A equal to sine B, then we can say A is equal to B. Okay, so make sure you are going to make the equation in this form, sine A equals to sine B, then you can equate A with B. So these are the angles, right? So here also we are doing the same thing, sine A equal to sine 30 degree. Okay, because sine 30 degree is having half, therefore A equals to 30 degree. Okay, this is how we solve the equations. Now let us take type 2 question, in which we are taking root 3 tan A minus 1 equals to 0. Okay, so this can be solved like this, tan A root 3 tan A equals to 1. First of all, shift this number on the right hand side. Okay, then we can say that tan of A equals to 1 by root 3. That means tan A equals to, now think, when does 1 by root 3 comes in case of trigonometric ratio for tan? So it comes for tan 30 degree. Okay, so in this way A equals to 30 degree. Okay, then let us discuss type 3. In type 3 we are giving a quadratic equation. Suppose we have sine A minus 1, this is question, sine A minus 1 into 2 cos A minus 1 equal to 0. Okay, that means either this into this, okay, equals to 0. as you do quadratic equation, either this equal to 0 or this equal to 0. So you write either sin A minus 1 equal to 0 or 2 cos A minus 1 equal to 0, right? So this will give you two values, just as you get in quadratic equation. This means sin A equals to 1 is that sin A equals to, for 1 you can write sin 90 degree, therefore you got one value A equals to 90 degree. Next, here we have 2 cos A minus 1 equal to 0, that means 2 cos A equals to 1 or cos A equals to half, that brings cos A equals to cos 60 degree. The value of cos 60 is half, so A equal to 60 degree. So your solution set will be A equals to 90 degree comma 60 degree, as you have two values in a quadratic equation. Now let us take type 3 question. So you see there are different types of questions that you may face in quadratic or simple equation or simultaneous equation in trigonometrical equations. Now let us take one example. We have a quadratic equation which is not split up in this format, okay? So the question is 2 sin A cos A sin A cos A minus cos A minus 2 sin A plus 1, okay, equal to 0. Now if you observe this equation, okay, in this you can take cos A common, what is left? 2 sin A minus 1, okay. Again in this you can take 1 common because nothing is common, so it comes to 2 sin A minus 1. Just as you do the factorization by grouping method. Now take the common factor first, that is 2 sin A minus 1 into cos A minus 1, okay. After that you can solve in the same manner as you have done this. That means if you consider 2 sin A equals to 1, okay, then sin A equals to half, that means sin A equals to sin 30 degree. So one value you got 30 degree. Another value, come on, cos A equal to 1, that means cos A equals to cos 0 degree, therefore A equals to 0 degree. So these are the two values, A equals to 30 degree, then we have 0 degree, okay. Now let's take a more complicated question. Now we have, this was type 4, we are taking type 5. Suppose if sin 2 theta equals to cos 3 theta, you have to find theta, then sin 5 theta, then cos 5 theta. So these are the possible questions attached. Now let's take this, sin 2 theta equals to cos 3 theta. As I told you, both the sides must contain the same t ratio, trigonometrical ratio. Either you can eliminate this in terms of sin or this in terms of cos. Now suppose we have sin 2 theta. Now for cos theta, we have sin 90 minus theta. So for cos 3 theta, can we write sin 90 minus 3 theta, right? Because sin 90 minus theta is cos theta. So for cos 3 theta, we have written like this. Now since both are now in terms of sign, equate the values, 2 theta equals to 90 minus 3 theta. So this is how the equations have to be solved. That brings 5 theta equals to 90 degree. So theta equals to 90 by 5, that is 18 degree. So we got the first answer, theta equals to 18. Now the second part, that is sin 5 theta, you have to find out. So this means sin 5 into 18, and that is sin 90 degree, whose value is 1. Similarly, we have cos 5 theta, that means cos 5 into 18, that comes to cos 90 degree, whose value is 0, right? So this is one way to solve the equations. So we have come across quadratic equation, simple equation. Now we are coming to solve about simultaneous equation. There could be questions based on simultaneous equations also. Now look at this question. We have one question. 2 cos A plus B equals to 2 sin A minus B and this is equals to 1, right? Find A and B. Angle A and B you have to find out, okay? So you can equate this with this, okay? In equation we have only two terms, left hand, right hand, okay? There can't be three terms equated. So equate the first with the third term. We have 2 cos A plus B equal to 1. That brings cos A plus B equals to half. 2 goes that side, okay? So that brings equation cos A plus B equal to cos 60 degree, because the value of cos 60 is half. So we got one equation A plus B equal to 60 degree. Let's say this is equation 1. Again we have this equation 2 sin A minus B. Now equate this with 1, okay? So we get the equation sin A minus B equal to half. That brings sin A minus B equal to sin 30 degree. So the equation now, second one, is A minus B equal to 30. This is equation 2, okay? Now you have to solve these two equations by simultaneous equation, because there are two variables. So we have A plus B, one equation equals to 60 degree, and second equation A minus B equal to 30 degree. On adding, this gets cancelled. So 2A equals to 90 degree. That brings A equal to 45 degree, right? Now putting the value of A in this or this equation, you can get the second part. Since A plus B, this is 60 degree. Now put the value of A 45. So the value of B comes 60 minus 45. So B is 15 degree. So the values of A 45 degree, the value of B 15 degree, okay? So this is how you have to handle the equations based on trigonometry, okay? One more question we are going to discuss. You are given the question 2 cos square A minus 3 cos A plus 1 equal to 0. Now if you observe this, first of all, this is a second degree equation, okay? So this is a purely quadratic equation to be solved by trinomial method, middle term factorization. So multiply 2 into 1, that is 2. So you have to break up the middle term 3 cos A as minus 2 cos A minus cos A, just as you do in factorization method to solve the quadratic equation, okay? Now take 2 cos A common. We have cos of A minus 1 minus, here nothing is common, so you can take 1 common, again cos A minus 1. So that brings our factors cos A minus 1 into 2 cos A minus 1 equal to 0, okay? Now you can do by equation, either equating this with 0 or this with 0, as you do in quadratic equation. So either cos A minus 1 equal to 0, that means cos A equals to 1, or we can write cos A equals to cos 0 degree, therefore A equals to 0 degree. Then we can take the second equation, 2 cos A minus 1 equal to 0, that is 2 cos A equals to 1, that brings cos A equals to half, or cos A equals to cos 60 degree, so A equal to 60 degree. So we got two solution sets, one is 0 degree, the other is 60 degree, okay? So this is how you need to solve the questions, okay? Not always the questions could be like this in the same trigonometrical ratio. Okay, sometimes you might be having two ratios which are different. For example, let us take one question, 2 cos square a, okay, plus sin a minus 2 equals to 0. Now this is also a quadratic equation, but a true quadratic equation needs only one variable. That means either you have to keep the equation in terms of cos or in terms of sin. Now let's eliminate this. You know that cos square plus sin square is 1. So cos square a can be written as 1 minus sin square a plus sin a minus 2 equals to 0. Now open the bracket. 2 minus 2 sin square a plus sin a minus 2 equals to 0. Okay, you can cancel these two. Now we are left with, if you take sin a common, okay, we have 2 sin a with negative sign plus 1 equal to 0. Okay, so either sin a equals to 0 or minus 2 sin a plus 1 equal to 0. Then this means we can take sin a equals to sin 0 degree. Therefore, a equals to 0 degree. Okay. Now the next value, we can write 2 sin a equals to 1. That brings sin a equals to half. So sin a equals to sin 30 degree. Okay. So a equals to 30 degree. So look at the difference between these two equations. Okay. So you might be having a complicated questions like this. Okay, so there are different ways to solve the equations based on trigonometry. Okay, I hope the chapter is clear. So keep practicing. I have discussed and covered almost all the types. So thanks for watching. Okay.